So we've completed our study of recursion, though we're going to see it later in this course. And most students at this point either arrive at the conclusion, wow, recursion is an amazing technique, I can't wait to do more of it, or, oh wow, recursion, it's so complicated, I don't want to ever see it again. If you're in that last group of people, let me suggest you review the material, because understanding recursion, being able to use it, is a very powerful ally as you try to program and solve problems later in this course or even afterwards. We've seen that recursion is a very powerful technique, that we can go a long way with relatively little coding. The code often directly reflects exactly the computation we're trying to perform when it's specified in a recursive way, and that's a very nice thing. We've seen the two ingredients of recursion, the base case, that's the point at which recursion no longer proceeds, and the recursive call, which indicates further computation by recursion. Now, sometimes we're lucky and we're given the recursive structure in a formula that directly expresses the recursive nature of the computation. Other times we're just given a formula that's open and we have to find the structure ourselves. The best thing to do is to look at that large formula or the larger problem and find the next smallest instance of the same problem and thereby come up with the recursive formulation yourself. We've also seen the substitution model as a way of reasoning about recursion, walking through the code and plugging in values to see the values that are ultimately computed by a recursive method.